There are really interesting parallels with the built environment and passive house in general, like we're thinking about what are the embodied carbon implications of doing a better envelope, and a similar story.
That's the biggest thing, is that, wind and solar are now cost competitive.
Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavors of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your questions answered, and contribute to the community dialogue. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our weekly Passive House Accelerator live webinars. In the meantime, here's this week's Passive House podcast. G'day, welcome back to the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from Sydney, Australia.
And I'm Zack Semke, coming to you from Seattle, Washington. Sydney, Australia, that's not your normal spot. What's going on in Sydney?
It's not. Arrived here yesterday. Very excited to be heading along to the South Pacific Passive House Conference today. Really looking forward to catching up with a whole bunch of people, and got a presentation talking about the Passive House podcast and Passive House Accelerator. And you're joining the program tomorrow.
I am. Yeah, I'm going to be talking about Passive House and Solar Punk. I'm actually driving down to Portland tomorrow, where Passive House Northwest is having a mini conference on embodied carbon and Passive House. So I'll be co-presenting with Skylar Swinford and Dan Whitmore there, and then patching in from Portland to Sydney. So get to join you virtually.
So I've been in Adelaide visiting my parents, and then flew across from Adelaide to Sydney yesterday, and it's pretty hard to miss all the solar panels on roofs in this part of the world. And I know it does come up briefly in today's conversation, but it is very obvious when you fly in and just see such a large number of solar panels on roofs here. Partly that was due to some pretty big subsidies that were available across the whole country over the last decade, and it's definitely having a significant impact. But it's also just fascinating jumping across the ditch, coming from New Zealand to Australia, and seeing all the things that are similar in the built environment and urban design in general, and the way houses are built, but a lot of differences as well. And I guess it might be similar traveling between states in America, where there are lots of commonalities, but there are also local differences in how things are done, and differences in the market, different materials supplied. People, the cities here are grappling with growth. So there's a lot of urban sprawl because there's a lot of flat, easily developed land on the outskirts of both Melbourne and Sydney. So those cities are getting massive and just spreading out, which is causing some problems. So yeah, very, very interesting being here and just kind of as an observer and watching all of that stuff happen. But anyway, we should crack on. We are going to talk about solar today, which is a little bit different and also very interesting. I really enjoyed listening to that interview. But before we get into that, quick shout out to our sponsors.
Yes, a big thank you to our founding sponsors, 475 High Performance Building Supply, Baxt Ingui Architects, Glavel, Minutair, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stocorp, and Zola Windows. Thanks too to our champion sponsors, Bewiso, Icon Windows and Doors, Intelligent Membranes, Proseco, and Source 2050. And a big thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Zach, how did you come across our guest this week, Tim Montague?
Well, I have been aware of Tim's work for quite some time. He is the force behind the Clean Power Hour. He was also part of the Passive House community about 10 years ago when he was doing some consulting work around marketing and organizational development with FIAS. And so I've been, connected with him on social media and those sorts of things, but I haven't really had a chance to sit down with him and talk. He runs this other podcast called the Clean Power Hour. The Clean Power Hour, of course, is all about clean energy and solar energy and wind. Passive House is on the building side of this clean energy transition we want to see happen. So we have different but sort of kindred spirits in terms of audience. And so it was fun to connect with him and have this chat.
Yeah, well, and a lot of parallels in there as well, which is really great. So let's get into it.
Well, I'm really excited to have Tim Montague here on the Passive House podcast. He's host and creator of the Clean Power Hour podcast, among other things. Tim, welcome to the podcast.
Thanks so much, Zach. It's good to be here.
Yeah, it's great to have you here. And we're doing a little bit of a swap. So we'll be doing an interview with you for the Passive House podcast. And then I'm really looking forward to being interviewed for the Clean Power Hour podcast. So listeners are going to witness, you're a solar guy, you're a developer and consultant on a bunch of solar and storage projects, which I'm really looking forward to diving into in this conversation. But first, you've got some Passive House roots too, right? Can you share those?
I do. I moved to Urbana in 2008. I was just casting about for new opportunities. I moved down to Champaign-Urbana, home of the University of Illinois, specifically to work at the U of I. And I did eventually get a job there for a science and research technology institute called the Beckman Institute, which is an interdisciplinary science and technology research institute, which was a wonderful place. But I learned about FIAS at that time that was based in Urbana, founded by Kat Klingenberg. And I slowly built a relationship with her over the years and did some consulting with them starting in 2012. So I'm a lifelong marketer and B2B sales and business consultant. And the threads that connect my various careers are sustainability, people, and technology. And so Passive House is a great combination of those things, just like solar is. And Passive House is, of course, involves many, many more technologies. Solar is kind of a walk in the park, relatively speaking, compared to designing and building whole buildings. But yeah, it was just my local opportunity to bump into and build a bridge to FIAS and FAIS.
Right. And so you were doing marketing, you were helping them with marketing and some organizational development at that time. What was the nature of that work?
Yeah, exactly. They had really made most of their money from training. This is architects and engineers and designers to become certified Passive House. That's, there are many flavors of being a certified Passive House professional now, and so I was helping them figure out the future and how to diversify their streams of revenue, including more traditional fundraising, corporate relations. Of course, Passive House is full of opportunities with manufacturers of windows and doors and HVAC systems and ventilation systems and heat pumps and insulation, et cetera, right? These things that make a passive house and differentiate it from traditional construction. And I don't know if I succeeded really, but I did create a good plan for them. I would love to revisit that with Kat now 10 years later and see what her thoughts are. But
yeah, absolutely. Well, I mean, FIAS is certainly grown in leaps and bounds as an institution since those days. So that's awesome. Okay, so how about solar? Like, were you already involved in solar development at that time, or is that something that developed after 2012?
It was really only a glimmer in my eye. When I moved down here, we got our first renewable portfolio standard in Illinois in 2008. An RPS, as we call those, is really the foundation of a solar industry. If you don't have a robust RPS, you very likely will not have a good, at least distributed generation or rooftop solar market. There are markets like Texas that are very robust solar markets that don't have robust RPSs. So it's not a must-have to have a robust market, but those non-RPS states are mostly utility scale markets. So Texas has a lot of utility solar and batteries happening now. Florida is another example of that. But for the rest of the states that want to have like residential and commercial rooftop solar, you need an RPS because this technology is still expensive, relatively speaking, to dirty coal power. And we subsidize dirty coal power, right? Because we're not paying the full price of the pollution, the carbon pollution and the particulate pollution. Burning coal and fossil fuels kills 6 million people a year, literally on Earth. It is a huge price that we are paying as a society, and yet it's free for the people that make fossil fuel energy. They don't pay for that. You and I pay for that with our health, and then the system that we support that provides public health to society. It's really a burden on society. And then, of course, there's climate change, which is a near existential threat. I wouldn't say it's an existential threat. Humans will survive catastrophic climate change. We are going to figure out a way to put things together, so to speak, but it could knock us back in time. It could make life very difficult for modern humans. And I don't want to live as a caveman. We did it for thousands and tens of thousands or hundreds of thousands of years. It's more comfortable to live in a conditioned home with an HVAC system. And once you give humans these things, right, they gravitate to that level of comfort. So anyway, I got into solar because it was in my blood. Like I got exposure as a kid in the 70s in New Mexico. My dad was fighting coal in the Four Corners area. Oh, wow. There are some ginormous coal facilities there that are now shutting down and being replaced with batteries and solar. Great solar resources, right? Lots of real estate. Good place to put solar. And he actually talked to the Navajo Nation about doing solar back in the 70s. And they were like, we're kind of digging this coal thing we got going. Yeah. Because it was jobs, right? Coal mining and running the power plants was a lot of jobs, as well as uranium mining. The nuclear industry is very robust in the Southwest. We have, government research laboratories there that designed and built the first atomic weapons. So there's a legacy there. That also is jobs. But the future is wind, solar, and batteries. And I saw that and got in 2016 full-time in solar and haven't looked back for a second.
Yeah, right. Really interesting stuff. I mean, the RPS, the role of the RPSs and how that enables rooftop solar is really interesting too. And it points to the fact that grid solar is so much cheaper, right, than rooftop solar is to develop. So you have in a place like Texas, you can see grid solar take off without an RPS. Isn't that partly because grid solar actually does compete on the economics with dirty energy more and more these days?
That is true. At large scale, we call it utility solar or utility wind.
That's right. That's right. Not grid, and utility.
Really the cutoff is around 10 megawatts these days. It depends on who you ask, but 10 megawatts and larger is considered utility scale. These are like 50-acre solar farms or several 100-acre wind farms. Wind needs a little more geography, obviously, but you're just using a small amount of that real estate and you can still farm or graze or whatever you're doing with the land underneath those wind farms. And solar and wind are now the cheapest sources of new energy and the fastest growing sources of new energy on the grid. They have surpassed coal. Even our sheer generation now of coal is less than wind and solar. So on a mass scale, the install base of wind and solar is bigger than coal power. Coal is declining, and then nuclear is just flatlined. We just commissioned our first nuclear power plant in Georgia, a plant called Vogtle, which was, 15 years in the making. Huge financial boondoggle. Georgian ratepayers are paying dearly for that. The price tends to go up much greater than the estimated cost, which is why we're not building nuclear power plants. And that was the first one, I think, since the 80s that we turned on. So anyway, wind and solar are the cheapest, and therefore all of the utilities are just dogpiling in. And we've got this aging fleet of coal and natural gas plants that are getting sunsetted. You know, a coal plant can generate electricity for maybe 14 cents a kWh, a new coal plant. You can generate wind and solar for 4 cents.
Yeah.
And you know, once you have subsidies like we have in Illinois, you can I'm selling solar power purchase agreements at around 3 cents for commercial industrial facilities. That's why these RPSs are so important. We now have 100% RPS in Illinois and a handful of other states around the country: New Jersey, New York, California, maybe your home state. I'm not sure, but there's a handful. There's over 100 cities and states that have set 100% goals now, and it's just a matter of time before everywhere across the globe has these goals. It's not a question of if, but when, right? Like, we will achieve a net zero economy. Can we do it fast enough to step back from the brink of catastrophic climate change? That's only the future will tell.
Right. And when you say 100%, it's 100% renewable or clean, probably 100% clean energy by a certain date.
Yeah, in Illinois, we have what's called a 100% carbon-free goal because we're a heavily nuclearized state. 40% of our grid power comes from nuclear power plants. We're the most nuclearized state in the country. And that is, again, a legacy from the bomb, the research that went into the bomb in the 1940s. But once you build those huge machines, these are gigawatt and 1 and 2 gigawatt power plants. They're big power plants. Once you build that huge hunk of steel and cement, it's good to keep it running because it is relatively zero carbon. Of course, you have to do mining and then refining to make the uranium that is, for all intents and purposes, burned. It's not burned like coal is burned, right? You put it in a concentrated container, and because it's radioactive, it generates a lot of heat. Then it generates a chain reaction and generates a whole lot of heat. And then you boil water and make electricity with that steam. So anyway, we will include nuclear in our 100% goal. Now, nuclear is 40%. That's not going away. Maybe some of it will go away by 2050, but certainly there's a decade to 2 more decades of these plants just keeping them running. That is subsidized by our legislation called CEJA, the Climate and Equitable Jobs Act, which is the foundation for this RPS that we're speaking about. And then wind and solar will really make up the bulk of the other 60%. Today, the bulk of that is coal and natural gas.
We talked a little bit about how prices have been dropping during this period that you've been working in solar. What else has changed since you've gotten started in that landscape?
That's the biggest thing, is that, wind and solar are now cost competitive. I got into solar because a gentleman named Paul Johnson called me out of the blue. He lives in British Columbia in Canada. And he said, "We've reached grid parity with solar. You should get into solar." Now, this was a wake-up call because I had seen a huge tranche of wind come in to central Illinois. That's what we got with our first RPS back in 2008. We had a 25% by 2025 RPS, and that led to a couple of gigawatts of wind and a small solar program. But it was really, it was 1G, 2Gs. We had 250 megawatts of solar in 2017 when we got new solar legislation. Now we have over a gigawatt of solar, and we're installing about half a gigawatt a year. So price is a big game changer. And I think just generally our industry is now becoming a mature energy industry, not a sideline. We've become the fastest growing source of energy on the grid. And so traditional companies that traditionally ran coal and nuclear facilities are now also running solar, wind, and battery facilities. These are what we call IPPs, independent power producers. And many of these companies are European utilities. I do development with a company called EDPR. EDP is the national utility in Portugal. There's companies like Engie, a big French company. Engie built the Suez Canal, huge industrial company. They own all kinds of power plants. Now they're big into wind, solar, and battery storage because that is the nature of the energy economy. And it's a win-win, of course, because it's clean jobs, green jobs, and decarbonizing the economy. And it's a way to make money if you're into running power plants.
Yeah. And that's so exciting. And to see everything scale up in response to how the economics have changed is also heartening as we look at this race that we're in with the climate crisis.
Yeah, it's a total game changer. Only a fraction of professionals in the business world care about sustainability. I estimate about 10%. And even though Larry Fink at BlackRock talks a good game, he sends a letter to his investors every year saying, look, you have to set ESG goals or we're going to kick you out of our fund. Well, it doesn't really have teeth. And so, there is a certain truth to Elon Musk saying ESG is a bunch of greenwashing because Tesla is one of the greenest companies. We don't give Tesla enough street cred or credit for what they've done with, decarbonizing transportation and really setting the electrification of transportation on fire in the U.S. You go to Europe. I just was visiting Norway, where my oldest son lives. He's going to college there in a town called Ålesund, and 80% of new vehicles are plug-in hybrids or pure BEVs, battery electric vehicles. We're knocking at maybe 6%, I think, now in the United States, and it's like 20% in California, right? California is way ahead of the other states when it comes to adoption of electrification of transportation. So anyway, that's another thing that we've seen just take off, and soon the ICE engine will be a true dinosaur, and it'll just go away because of the economics.
Right. You have a product that will be cheaper. It is already clearly vastly better in terms of performance.
Yeah, fewer moving parts. Like these vehicles can go 1 million miles because they have so many fewer parts.
So, as thinking about a little bit about our audience here and architects and builders in general, what do you wish that architects and builders understood about solar and storage?
Yeah, great question. And I love seeing solar get integrated into the built environment. We truly will eventually see a day, Zach, when all of the roofing material and all of the cladding, including windows, will be a generating material that will make electricity, at least on those surfaces that are exposed to photons. I can understand if, like the underside of the roof may not, right? But when you go to Europe and you go to Asia, they are making products, and these products are going mainstream with cladding and windows that make electricity. We're playing catch up in the United States, which is very ironic because we invented that technology. The modern PV photovoltaic cell was invented at Bell Labs in New Jersey in 1954. But so I would say design your roof to be solarized. Okay, first and foremost, like using traditional crystalline, you need open space. You don't want vents. You don't want obstructions because those make it difficult to put panels. You need space. That's the only thing, right? So you need a big, wide open roof. And it is hard with multifamily. There's no doubt, right? Because the roof area to the volume of the building is small. And so you're going to have to put solar on the land next to the building or participate in a community solar project,
Right.
and it's a both and now
Right.
we have places with community solar, which is a wonderful thing, right? Why not build a solar farm out in the countryside and then sell that power via virtual net metering, just computers doing that calculus, and then you don't have to worry about putting the solar farm on the parking lot, which is doable also.
Mm-hmm.
And I love photovoltaics on parking lots,
Yeah, why not?
carports. They're just a little more expensive, maybe as much as 2x a traditional just rooftop array. So, but it is interesting that architects still are a little slow to design things for solar, because when you look at the landscape of a state like Illinois, a tiny fraction of the rooftops have solar on them, right? And so you go, well, maybe in 10 years I'll do that. Well, you got to design now, right? All the new buildings that are being built in the United States should be designed to have solar on site. And because whether it takes a few years before that happens, it's going to happen in the lifetime of the building. The building's going to be around for at least 50 years, hopefully 100 years, right? Hopefully we're designing buildings to be used for at least 100 years. Yeah.
Yeah. It's interesting that trend to cladding the buildings in solar voltaics is beginning. Like there's a multifamily project in Salem Heights, a passive house project that the Preservation for Affordable Housing is doing that is wrapped in PV. And there's also that really fun and kind of crazy project by Timothy McDonald of Onion Flats in Philadelphia. I think it's called. I think the name of the project is called The Battery. But it's wrapped in solar panels. But that window piece will be fun to see that start to actually show up in projects. I'm not aware of any that technology making it out yet.
Yeah, when you go to Europe, you do see high rises that are clad in solar glass now.
Yeah.
And it's still more expensive.
Mm-hmm. Sure.
You're not getting, like a traditional crystalline panel, you can get 24% efficiency. If you go to a window that makes PV, where it has PV integrated, you're going to go down to maybe 10% or something like that, right? But you've got a huge surface area, so you don't need you don't need great efficiencies. We have way more energy coming from the sun, something like 2,500 times more energy from the sun. And this is post-electrification. Today, it's like 5,000 times more sun, but we're going to triple the grid. We're going to double or triple the grid, right? When we convert heavy industry and transportation to electricity, which we're going to do, right? We're going to get rid of coal in steelmaking, for example, and other thermal processes. For the food making industry uses a lot of thermal heat. Today, it's natural gas, primarily the fuel source. Tomorrow, it'll be both solar thermal and solar PV. Bada bing, bada boom, and you've got a clean industry. But we're going to need a lot more electricity in general. And so I say go to Europe. If you want to see the future of the energy grid, go to Europe. Energy is very expensive in Europe. Gasoline is 4x in a place like Norway, and of what we pay. And that's really the only reason we've been slow to adopt, is we're running our economy on cheap fossil energy. We have lots of it, and we externalize those costs, as we talked about earlier in the interview here, that nobody but, we're paying for it mostly with our health and the health of future generations who are going to pay for climate chaos. My children and our children and our children's children and all future generations are paying dearly for something that we've known about for over 100 years, right? This effect that carbon has when it gets in the atmosphere, it's not rocket science. And so it really is we have to wake up and just go whole hog into clean energy. Otherwise it's just going to be a mess.
Yeah, I couldn't agree more. So what do you see as the biggest hurdles right now to solar and storage development and adoption? What are the roadblocks?
I would say number one is awareness. We still have a lot of facility owners and a lot of building professionals who don't realize that we've gone as far as we have with the price of technology and the there's this thing called the cost adoption curve, and so as you double the number of installations, the price of the technology drops by 25%. It gets cheaper. So solar has gotten 80% cheaper in the last 10 years in the United States. Now we have a long way to go. It's almost half as cheap in a place like Australia or Germany to install rooftop solar because they've streamlined the process so much more than we have. We have expensive soft costs, the cost of getting the permit, the time it takes, the amount of brain power it takes on various ends, not only the installer, the developer, but also the AHJ, the authority having jurisdiction. Everybody has to spend more time and energy than they should. But so just awareness among industry professionals, but also facility owners, right? Like, this is a thing. You can design your building, or you can retrofit your building. It's a both and. Just like you can retrofit your building to become passive house, super energy efficient, you can retrofit your building to be solarized, and that's a good thing. And then yes, we every state needs a good foundation with an RPS and legislation. There's a handful of really good states right now, states like New York, Massachusetts, New Jersey. Now Illinois is in their midst, Minnesota, out in the Pacific the Pacific Northwest, Oregon, Washington, California, and then down into the Southwest, Colorado, Arizona, New Mexico, Texas, and then coming around, for utility scale like Florida. It's ironic, right? Rooftop solar is not a huge thing in Florida because the utility has squashed that industry and pushed back on that industry so much. And but they're busy building utility scale solar farms because they want to sell that cheap electricity to their consumers.
And how about the Inflation Reduction Act? What impact do you see that having moving forward?
Yeah, that has been already a huge game changer. That just came into force last year, and it was signed last year, and now it's taking effect in Q1 of 2023. It gives us a good long 10-year runway on things like the investment tax credit, which is 30% of the solar facility. We get standalone incentives for storage for batteries, and then other incentives for energy communities, made in America incentives for manufacturing. And this applies to solar, wind, batteries, electric vehicles. And so, for a solar project, you can get as much as 60% of an investment tax credit when you focus on low and middle income communities, energy communities, and using made in America products. So the IRA, or IRA as we call it, the legislation, is a complete game changer. It's what I call very good industrial policy.
Yeah.
It's how we got things like a national highway system, right? It's not something that private industry is going to do on its own. Government, this is the vital role that good government plays in our lives, is creating a foundation to incentivize the adoption and installation of these technologies. We have the technology. Now we just need to deploy it as fast as possible. And the IRA is a shot in the arm. It's going to accelerate the adoption of the installations and the manufacture of the panels. Like companies like Q-Cells and Hellion Solar and First Solar are all expanding their factories in the United States. So we're seeing a kind of a new industrial revolution, Zach, in the United States around clean energy and electrification of transportation. There's also incentives for heat pumps now, right? We need to make those heat pumps in the United States. They're generally made in Asia or Europe. I would venture to say that FIAS or passive house certified professionals are much more familiar with European products and Asian products than they are with American products, because we traditionally haven't made those products in the United States. And we are now going to start doing that en masse.
Yeah. It's so encouraging to have the federal industrial policy, getting behind this clean energy transition and accelerating it, and build, I say, for sure.
Yeah. And there's major incentives for energy efficiency. Like I was telling a young colleague of mine today who's getting a degree in international business in Washington, D.C. at George Washington University. The energy efficiency industry is probably 3 or 4 times as big as the clean energy industry, right? Because it impacts so many more aspects of the built environment. And so it's a both and, right? We
Absolutely.
We have a lot of work around decarbonizing the built environment, the embodied energy in building products, but just designing and building and then retrofitting buildings to be 90% more efficient, right, than traditional construction, which is kind of the watermark for passive house.
That's right. I'm glad you brought up embodied energy. I think that I was thinking about this conversation earlier today. I was thinking about there's a little bit of a parallel with the embodied carbon and operational carbon question in buildings, and the embodied carbon and clean energy generation question in solar panels, right? So I'd be really curious to hear because you do hear people bring up the concern, well, what about the upfront carbon of panels and the carbon burp of that? And is that something to be concerned about? Can you talk about that a little bit?
Absolutely. You want to know where your solar panels are made and how they're made. There's, you could make a solar panel using coal power, and it's a dirty solar panel. And many solar panels are made this way in China. Now we have an organization called the Ultra Low Carbon Solar Alliance. Just Google that. I know it's a mouthful, but the Ultra Low Carbon Solar Alliance. And they are creating a standard very similar to LEED for buildings for solar panels, to incentivize manufacturers to adopt standards so that then they can have a stamp of this panel is made with clean energy. You can make electricity with wind, hydro, solar, et cetera, then run your solar panel factory using that clean energy, and therefore make a much lower carbon footprint solar panel. You're never going to get rid of the carbon footprint altogether, but the solar panel will pay itself back much faster. Already a dirty carbon or a high carbon solar panel will be carbon neutral after just a few years of operation.
Yeah.
Okay.
Yeah. When
you're supplanting coal and natural gas, fossil energy from the grid. So even a bad solar panel is still a good thing, but we want to incentivize and create more standards and awareness around you can create low carbon solar panels, and companies like Q-Cells are doing this, and they're very serious. This is a Korean company, powerhouse. They're expanding their factory in Georgia. They're doing soup to nut solar panel manufacture now, or they're building a factory to do this from the metal ingot, right? Silicon, they call it silicon metal. It's a huge tube of cylinder of silicon that's then sliced into wafers. That's made into solar cells, and that's made into solar panels. And right now, most of the manufacturing in the U.S. is what we call panel assembly. So they're buying solar cells from overseas and then putting it together in an American-made panel. But this is the thing. So everybody who makes parts of the supply chain from the silicon and the aluminum and the glass and the solar cells then will have to document that they're making a low carbon product. And we can do this. We have the technology. You just have to get serious about making green aluminum and green steel and green copper and green glass, et cetera, et cetera.
Yeah, that's super interesting. Thanks for sharing that. There are really interesting parallels with the the built environment and passive house in general, like we're thinking about what are the embodied carbon implications of doing a better envelope, and a similar story where if you made really bad embodied carbon decisions, really high GWP foam insulation like XPS foam, you can why would you make those decisions? But if you were to make those decisions, a passive house envelope is going to pay off that carbon burp within the first several years of operation. But if you choose to do, you can actually do carbon sequestering materials in your envelope and basically it's a both and story. For sure. So it's cool to hear about that ultra low carbon solar alliance. I hadn't heard about that, and it makes a lot of sense that standard is on its way.
Yeah, I'm curious what other industries, when it comes to like insulation, which is so vital, right, in passive house, or things like heat pumps, these elements
with their refrigerants. Yeah.
And just the metal parts, right? Heat pumps are a commodity product. They're consumed, by the billions now. And you can make a dirty heat pump or a clean heat pump, I'm sure. A tiny fraction of manufacturers are getting serious about decarbonizing their processes. It is happening. Companies like Volvo, right, are using green steel now. And it's totally doable. You just have to be serious about it, right? It's not going to happen by itself.
Right. Yeah. And one of the insights that Skylar Swinford has in our community has been sharing is that when we do ultra energy efficient buildings, and let's assume we're doing electrified buildings moving forward. So heat pumps. Yeah. If we have ultra energy efficient buildings, it means a smaller heat pump, which means smaller upfront carbon emissions for the metals in that, but also importantly, a much smaller volume of refrigerant. And today, those refrigerants have a high GWP. That, of course, will change. Like everything, that will improve. All of these variables that we're grappling with now, as we're working towards zero carbon buildings, are progressing and evolving and changing. So the math will continue to do the same.
Yeah.
Super interesting. Been super fun to talk about and something really different for Passive House podcast listeners. I think people are really going to enjoy this conversation and getting somewhat of a primer and snapshot of what's going on in the solar world. Is there anything you'd like to add before we wrap up?
No, I really appreciate this conversation. It's a homecoming. I love the passive house industry. It is a very important force for decarbonizing the built environment. And it's again, you go to Europe and they may not call it passive house, but many Northern European countries have adopted building codes that are effectively passive house or equivalent, right, for super energy efficient. And it's because energy is expensive, like in dollars and cents. What we have to remember is that even if we have cheap energy, there is a price, and it's mostly being foisted on low income people and future generations. So I really enjoyed this.
Yeah. Awesome. Well, thanks for your time, Tim. Appreciate it.
All right. Thanks, Zach.
And that was Tim Montague, who, among other things, hosts the Clean Power Hour podcast. We'll put a link to that in the show notes, and people can check out your interview there, Zach, sometime in the future. I'd had a brief look, and there's some pretty interesting topics there. They do a pretty deep dive into the whole world of solar, as you would expect, across I think it's quite US specific, but very interesting to see nonetheless. I really enjoyed that. It was a little bit different from our normal guest, but I think really useful as well. One of the first things that stands out for me is Tim's background in the sales area, sort of B2B sales, and I am interested in that because he's obviously done a lot of thinking about the business of solar, but also the business of sustainability, the business of lower carbon, the business of just building and energy production, energy use better. And I think there's some really valuable lessons there for us in the passive house world, thinking about what the market is, what people are willing to pay for, particularly what investors are willing to invest in, what makes good financial sense for them. And obviously what's made a big difference in the solar sector are these subsidies, and he mentioned right at the start there, the standards, the RPS, which I hadn't heard of before, renewable portfolio standards.
Right.
But a lot of that's setting the stage for the adoption of these things and the creation of a self-sustaining market. So I think things like solar are a really good example of where well-placed policies and subsidies at the right time give a new technology a bit of a leg up and help to establish an industry, and there becomes a tipping point at which they just make economic sense. And that seems to be happening now with some of the figures that Tim was talking about, and it just being cheaper now to actually, if you're going to create a new power plant, it makes a lot more sense to have that be either wind or solar, just from a pure economics point of view, let alone pollution and mining and coal and all the rest of that. So that's really exciting. And I don't know exactly what the parallel there would be for the increased uptake of passive house, but I feel like there are some good lessons, particularly around the importance of knowing your market, knowing what is driving it, and what incentives and subsidies and standards help to create that drive and increase the uptake.
Yeah, absolutely. And I think that I think what's special about what we've seen in the clean energy space, and particularly with solar energy, but also batteries and wind, is that these early subsidies have helped drive adoption, and we have that the Wright's law or Swanson's law. I think that Tim.
Is that the price adoption
referred
curve?
to it as the solar cost curve? But yeah, it's just, every time we double the deployment of solar energy, the cost of solar energy goes down by somewhere between 20 and 25%.
Yeah,
and so you have these we can also give big thanks to Germany for their tariff policies that feed in tariff policies that help to spur on solar adoption in Germany, and therefore drive the cost curve down for all of us. China has that what's been going on in China. All of these have implications for the global economy of clean energy. And then you're right, with these RPSs in each of the states, or many of the states anyway. There's that continues, and so we have this cost decline of whatever it was, 90% in the last 10 years. I was just listening to Ramez Nam, really great thinker and speaker around the clean energy transition, and he was pointing out that 13 years ago, the International Energy Agency was making a bunch of projections. Well, that's what they do. They make long-term projections around solar uptake, both in terms of number of solar panels that will be deployed and the cost of those panels. Those back in 2010, we have beaten in terms of solar panels have beaten the cost projections by anywhere from decades to 100 years. We've gotten like, the decline has been so phenomenally fast, and that's due to that learning curve and the fact that we're not talking about coal and oil, which are not technologies. They're extractive energy, and so like the next scoop of coal will naturally be more expensive than the one before it. That's not the case with deployment of solar and wind and batteries. And so I think that the interesting parallel here is that we in the passive house world also have a technology. It's the houses, the buildings we do are technology. We're using information systems to dial and optimize the design of these in, and the moves that we're making in the five classic principles, all the different design principles that we use in passive house can be understood as technology as well. So we can have regions like Pennsylvania adopt, a policy that encourages passive house development, and we see the cost curve go down between passive house and conventional construction. So I think that it's not the same, but there are parallels in terms of the role that public policy can play in spurring on the adoption of this technology and the improvement of our practice in it, and therefore bringing the cost down of these buildings.
It was interesting Tim mentioned Australia briefly when talking about how in some places that cost of installation has come right down because of a big push. And that's what happened here. There was a big scheme that basically forced energy suppliers or solar, I can't remember exactly who, but basically, I think it was an energy retailer, so electricity suppliers had to pay consumers quite a high rate for anything that consumer generated on their own roof. So they had these sort of forced rebates, and that shifted the equation quite substantially because it made the solar decision economic for the household. And then there was other subsidies on the actual installation costs and sort of zero loan schemes, things like that helped get you over the hump of the initial capital cost. But the more important driver initially was the ongoing benefit that consumers would get. And that was an artificial market. It definitely pushed the industry, and it wasn't sustainable to maintain those artificially high feed-in tariffs. But it was enough to kind of get over the hump of establishing an industry and getting things going. There's always a bit of a risk with, I think, manipulation of a market like that, and because you risk setting up an industry that relies heavily on subsidies and rebates. But done well, and if you sort of match it with that technology curve and all the other things that are going to ultimately bring down the costs for suppliers, then I think it can be very successful. From a passive house point of view, I was interested that Tim said that one of the biggest challenges for his industry is awareness, and I think that's another important parallel for us because we, in passive house world, we're at a conference this weekend. We're going to be surrounded by people who are totally into passive house. And sometimes we forget that if we just walk outside and ask someone about passive house, they probably don't know what we're talking about. That was probably once true for solar, or there was a lot of misunderstanding about it. And still, a lot of people don't know exactly how it works or how to get it. So I don't think we should ever underestimate how much we have to do in raising the awareness of passive house, because we know, and we've heard it so many times on this show, that once a architect or a builder gets the opportunity to work on a passive house project, they'll sometimes never go back, and if they do, it's sort of unwillingly go back to doing what they were doing before. So if you extrapolate that out to the whole market, it sort of ripples out, and we just need to get more people exposed to passive house and all the downstream benefits of it. I guess the other connection I think is worth highlighting is Tim's point about designing a building now, assuming that at some stage in its life it's going to have solar on it, and I think that's a really good point, because there might be a bit of uncertainty at the moment, thinking where are things going to go in terms of generation and utilities, but that seems like a pragmatic approach to think about. I might not be doing it now, it might not happen in 2-5 years, but at some point in the future, it's very likely that some surface of this building will have solar panels on it. So whether that's the orientation of that surface, or maybe putting in some conduit for some cabling, whatever it is, it's worth thinking about in design. Lots of really good stuff, Zack. Anything else from you?
Oh, just on that last point, I think that that preparation for solar on rooftops doesn't necessarily even have to have anything to do with the net zero concept at the building scale, right? I mean, because some buildings are tall and have a lot of floors and not very much roof, and some are not tall and have lots of roof compared to the floor. But when we have roofs, let's put solar on them. It's basically we need to see more solar go up wherever it makes sense to do that, and as we ramp up massively, hopefully during this clean energy transition to lots and lots of solar energy and wind energy, the not in my backyard problem is going to be real, and there are real kind of equity questions about where it's okay and fair to site utility scale solar and wind. And of course, we're going to have to say yes to those utility scale systems a lot. But sometimes we're not going to be able to, there are places where it won't be appropriate. Well, rooftops are, a no-brainer for solar panels. Also really interesting to hear about the new technology stuff like, solar generation through windows in the future.
Yeah, thinking about pretty much any surface that could potentially generate. Yeah. Exciting stuff. Awesome. Hey, well, thanks to Tim and thank you, Zack, for bringing us that conversation. What have we got coming up?
Yeah, so this week at Passive House Accelerator Live, we have a next gen episode of the series. So we're on Wednesday, May 10th. So that's very early your time, Thursday, May 11th. We'll have Luis Aragon and Michael Schmidt of Stephen Winter Associates joining us for Tales from the Trenches, Passive House Ventilation Commissioning Roadblocks. And then the next day, on Thursday, May 11th for us at noon Eastern. So that's Friday, May 12th for you down under. We will have a special Passive House component spotlight with Rockwool North America. So Alejandra Nieto, Manaz Nikbat, and Robert Blunt will be presenting Rockwool, Passive House, and the 2030 Agenda for Sustainable Development. So also lots of cool stuff going on elsewhere by other parts of our community here in the Passive House world. So we'll include a link to those event listings in show notes.
Awesome. Check it all out on passivehouseaccelerator.com. I'm looking forward to, I'll have to catch the recording of that ventilation one. That's something I'm very interested in. We're just in the early days of trying to get ventilation installed, get people's head around what ventilation means, and I've already come across quite a few projects where the measured ventilation rate is vastly different from what it says on the box that the fan comes in. There's a whole bunch of reasons for that, so yeah, very interested to listen into that.
Yeah, it should be good. I also would be remiss not to plug our new YouTube channel.
Yes.
So the recording of those events that I just mentioned will be on our Passive House Accelerator YouTube channel, which is a library and archive of the presentations that we do, the live presentations that we produce. Reimagine Buildings is a new YouTube channel that is video that's produced for video. So right now you can go there and check out our Passive House Explained in Under 4 Minutes video, the first episode of our Passive Pads series, which is a tour of Michael and Diane Ingwe's Brooklyn Brownstone. It's a Enerfit Passive House retrofit of a Brooklyn Brownstone. And then also our piece focused on Winthrop Center, which is the largest Passive House office building in the world based in Boston. So, and of course, every week we're producing a new piece of video every week there. So please visit and subscribe and let people know about it.
That's a great resource to send people to spread the word if they're just finding out about Passive House for the first time. Send them over to that brief intro video. It's really, really great. So it's looking good, that channel. Great. Well, I'm off to a Passive House conference, so I will see you next week. We'll be back on Passive House Podcast.